All right. So over the last week, we've been talking about volumes of prisms, cylinders, cones, pyramids, spheres, and hemispheres. We're going to still look at those figures, but we're going to talk about scale factor today and ratios, which we've spent a lot of time discussing over this semester. Can someone remind us how we determine if figures are similar to each other? What were our qualifications back towards the beginning of the semester to determine if figures were similar?
Angles are the same and sides are proportional.
Perfect. So angles need to be congruent and sides need to be proportional. If you don't remember that, you should start remembering those things because you have a final exam in 5 weeks that covers everything from the semester. Okay, so you shouldn't just forget what we learned day one because it's not day one anymore. So what we're going to focus on are proportional sides. Okay, we're going to focus on proportional sides. Make sure you have today's date. This will be placed onto page 55. Now, when we were showing figures were similar and we were showing proportional sides, all of them, all the sides had to have the same scale factor, right? So, for instance, if I'm taking 50 from this figure, what would I compare it to in the smaller figure? 20. And what is 50 over 20 reduced to? 5 over 2. Okay, which means all of my sides, my length, my width, and my height, because that's how I would find the volume, need to all be proportional. So what would 30 match to? 12. What can I reduce 30 over 12 by? By 6, which gives me 5 over 2. And then what's my last side?
36.
90 and 36. And that reduces by 9. So if I reduce by 9, I get 10 over 4. Can I reduce 10 over 4? To 5 over 12. So because all three of those sides are proportional, these two figures are similar. Okay, again, we only have to look at those three sides because when we're looking at the volume of that figure, it's the length times the width times the height. So we looked at the length, the width, and the height. In a sphere, what is the only value we plug in? A radius. So that's all we need to compare. We'll get that in 1 second. So what is the radius of the larger sphere? 100? And what's the radius of the smaller sphere? 10. So I'm getting 10 over 1 as my scale factor. You still need to find the scale factor. There is nothing else to compare, right? For circles or spheres, it's not really, it can be both. Circles and spheres. I'll just write both of them in here. So circles and spheres are always similar. Okay, circles and spheres just get smaller and bigger. They will always be similar, but you still will have to find the scale factor. Remember, scale factors are ratios, so it needs to be a reduced fraction, no decimals. And you can put it in any order you want. Like here we went big to small. You can go small to big. Just make sure you read the directions. If it tells you specifically, I'll look for your answer that way. Okay. Since number 3 is the same as number 1, why don't you solve number 4 and determine if those two pyramids are similar? So because it's a rectangular base, you have your length, your width, and your height that you're comparing. So see if the two pyramids are similar. Can someone help me set up my ratios? Jordan? 20 over 10. Okay, so you did the heights. And you got 2 over 1. Okay. 40 over 20. Still 2 over 1. and 16 over 8, which is still 2 over 1. So if you did it small pyramid to large pyramid, you would have 1 over 2, and that's fine as well. Okay, so these are similar. Questions on determining if those figures are similar? No? Okay. This is the last lesson, by the way. Tomorrow we're going to do a review assignment. I think we're going to do Kahoot again. Oh, okay. We'll talk about that in a second. And then Monday you'll have a practice test. Tuesday, review it. Wednesday, test. Okay? All right. So in these examples, the figures are already similar. It tells us that in the directions. So each pair of figures is similar. We're going to use the information given to find the scale factor. So we're working backwards. Of the figure on the left to the figure on the right. So it tells us which order we want it to go in. What information is it currently giving us? The volume. Right? It's currently giving us the volume. So here's how we're going to set it up. We're going to start by setting up a ratio of volumes. So I'm going to write some steps off to the side. We're going to set up the ratio of volume. So we're going from the volume of the figure on the left to the figure on the right, and we're writing a ratio. So that's step 1. My ratio would be 1536 over 648. So far, so good? Okay. Step 2 is to reduce as far as you can. So we're going to completely reduce this fraction as far as we can get it. So we need to figure out what number goes into 1536 and 648. What number should we try? 6? Okay. So if I divide by 6, I get 256 over 108. I can tell I can go more than that because they're both even. Any other number we think might work? 2? Okay. If I divide by 2, I get 128 over 54. Does 4 go into both of those? What goes into 128 and 54? I don't think 2 does. And then that should give me 64 over 27. Is anything going to go into 64 and 27? Okay. So we set up our ratio of volumes. We reduce all the way if possible. If you found a larger number, so this is really, what, 24 went into initially both of those numbers? So if you start with a larger number, that's okay, but we're reducing as far as we can. Okay? Our last step, because this is still volume stuff, we want the scale factor. We're comparing the sides. Okay, so our last step is to take the cubed root of that ratio. Our last step is to take the cube root of the ratio because we're, again, looking for scale factor. We want to know about the sides, not the volume. Okay, and I'm going to show you a couple different ways we can do this, but we're going to take the cube root of both of those numbers. Now, we've taken a ton of square roots before, right? I'm going to just write on this real quick so you can see. So 64 over 27. This is the same as the cube root of 64 over the cube root of 27. And again, I'm going to show you 2 ways to do this so that you can pick the way that you like the best. So if we follow what we've been doing for square roots, we would factor. So what numbers go into 64? 8 and 8, and then 4 and 2, 4 and 2, 2 and 2, 2 and 2. And for square roots, we found pairs. What do you think we would find for a cube root? Groups of 3. So I have a group of 3 here. And I have a group of 3 here. The same rules apply. The groups now get to leave and go on a group date. Everyone else stays at home. So I have a group of 2s. I have another group of 2s. Do I have anything left over? No. So on top I would just have a 4. Okay, I would do the same thing for 27. What multiplies to 27? 9 and 3, and 3 and 3. Here I just have one group of 3s. So 4/3 then is my scale factor. Okay, so you can factor tree and find groups of 3 and do it that way. Or we can use our calculator. So, but I show you this way because half the time people don't remember how to use the calculator. So if I'm trying to find the cube root of 64, I can't plug that. Hold on, maybe I can. Oh, I can. I can plug that directly into my calculator. So see this button here that has the square root button, but it has a little X next to it? Okay, that allows you to take the cube root, the 6th root, whatever root you need to, other than the square root. So you're going to type in 3 first. I do second, and then my caret button, which happens to be the X square root button. And then I type in 64. And it still gives you 4. Okay, so why don't you try that with the cube root of 27 and make sure you still get 3. So 3 cube root, or so the cube root of 27, plug that in. Did you still get 3? Yeah? No, you do not have to show this work if you remember how to do it in the calculator. However, I'm not going to tell you how to plug it into the calculator on the day of the test. So if you can't remember, then you need to do that work. Okay, which is why I'm showing you both ways. So our final answer for scale factor then is 4/3. Okay, let's try another one. So these you're just going to have to remember the steps. The math is not hard, it's just remembering what to do. So you set up your ratio of volumes, you reduce, and then you take the cube root. Okay, we're going to do the same thing for number 6. I'm going to work through this one with you. So from left to right, we have 20,412 over 28,000. Let's try to find as big a number as we can that will go into both of those. So when you think you found a number, help us out. I'm sure 6 works. That doesn't go into the other one. Anyone have a decent sized number that 4 works? Is anything larger working that anyone can find? I don't think it went into the denominator. No. Anyone finding anything else? No? Okay, so let's start with 4, because that's what I was told. So if I divide by 4, I get 5103 over 7,000. I heard another number that someone thought worked. 7? Okay, so let's see if 7 works here. 5103 divided by 7. Yeah. Yeah, your large number ends up being 28. So, hold on. Since I started with 4, I'm just going to continue. Someone else said 7. 7 works. So I get 729 over 1,000. The biggest number that goes into both of those is 28, which is your 4 times 7. If you need to work slowly and go by 2, then you go by 2. Okay? Don't try to come up with like this crazy large number to make it fast, because it will end up taking you more time. 729 and 1,000 does not reduce anymore though. That is as low as that one goes. So I did step 2. Step 3 is to take the cube root. So in your calculator, if you remember how to do it, I would like you to take the cube root of 729 over 1,000. What did we get?
9 over 10.
9 over 10. Good. So my scale factor is 9/10. I would like you and your group to try number 7. So try number 7. See if you can go through those steps. All right. Let's see how you did. Are we still finishing? So you should have 13 pi over 6,656 pi. What's the first thing you did? Did you cancel out those pi's? Okay. Now, this one's a little easier, because I look at 13 and I can say the only thing that goes into 13 is 3. Oh, I thought I heard 3. I was like, no. Is 1 and itself, right? So I'm going to try to divide 6656 by 13, and it goes in nicely. So I have 1 over 512. I know 1 doesn't reduce anymore, so my final step is to take the cube root of 1 over 512. And what did you end up with? 1/8? Are we okay going from ratio of volumes to finding scale factor, or do you need to see another one? I'm going to take silence as we're good. Okay, great. Last section. Last thing you have to learn for this test. So I'm going to see if you can help me walk through this. So in the last problem, we started with ratio of volumes and we went to scale factor. In these problems, we're going to start with scale factor and go to ratio of volumes. Okay? So first step is to find the scale factor. You can compare any of the sides that you want. I already know they're similar, so all of them are going to have the same scale factor. Okay, so step 1 for these would be find the scale factor. So what do we want to compare here? You pick. 90 and 10? Okay. So, and does it say what order from left? Yeah, okay. So 90 over 10. Now remember, scale factor is completely reduced. So find scale factor that includes reducing. So what does that give me for scale factor? 9 over 1. Okay, that's my scale factor. Everyone okay with that? That's something we've kind of done. Now it says find the ratio of volumes. Anyone want to take a stab at how we might find the ratio of volumes? So on the front side, we went from ratio of volumes to scale factor. How do you think we work the other way?
You have to find the volume and then use them.
It's actually simpler than that. What do we know about the units on volume? It's cubed, right?
So you just
All you have to do is cube the scale factor. What is 9 cubed. And this practices your caret button, 9 to the third power, or 9 times 9 times 9. 729. And what's 1 to the third power? This is your ratio of volumes. So when we were going from ratio of volumes to scale factor, we took the cube root because we wanted to get smaller. Because we're going from scale factor to ratio of ratio of volumes, we're cubing it because it's going to be a larger number. Okay. Now you could find the volume of each. So if you forget how to do this, you could find the volume of each, set it up as a ratio and reduce, and you're going to end up with this number, which is really what we did on that front side. Okay, why don't you and your group try numbers 12 and 15? 12 and 15. Okay, just so you know, I added the second step. I forgot to do that. So cube the scale factor. What did we compare? Pick a side. Someone give me a side they compared. 81 over 63. Okay, if you used a different side, that's okay. You're going to get the same answer. I need to reduce 81 over 63. What goes into both of those?
9.
So 9 over 7. So there's my scale factor. And then I need to cube 9 over 7. 729 over 343. Did we get that? And again, it doesn't matter what side length you use. You're going to get the same answer. And then I said 15, right? Now this one we have to be careful. What sides did you compare?
12 and 28.
So Samantha just said 12 and 28. I don't see 12 right here, but we're comparing the radius of each, right? So 12 over 28 reduces to 3 over 7. 4 goes into both of those, and then we cube it, and our final answer is
27 over 3.
good. Okay, so the hardest part about this lesson, I know it doesn't seem hard, but when you have to do this on your own, the hardest part is remembering which one you start big and cube root to get small, and which one starts small and you cube to get big. Okay, so remember, scale factor to ratio of volumes, you cube it. Ratio of volumes to scale factor, you take the cube root because you're going smaller. And then creating a scale factor, we should be okay because we've spent time doing that, right? Are there any questions, comments, concerns? Do you need another one? Are we okay? Yeah.
What happens if the ratio is like weak?
If you simplify this ratio, this one simplifies? Oh, it won't. So the only way for you to simplify it is to take the cube root, but then you go back to the scale factor, which is where you started. Any other questions, comments, or concerns? Okay, make sure this gets attached to page 55. This is the last section before your test.